Good afternoon. Afternoon. Welcome. My name's Christopher Callaghan, and I'm the Chief Science Officer at Jersey Hemp. And I'm going to talk to you a little bit, following on from what Glyn has talked about, of how we're actually really trying to implement this in a real-world environment without the cost of any loss in productivity or commercial output. So, I'll briefly talk to you about what industrial hemp is, some of the environmental benefits, how the methods in cultivation impact the carbon retention, drawdown and sequestration, and the same applies to the end product as to what is used, what the plant is used for will determine whether the carbon is released back into the atmosphere or the carbon is retained within the product or environment of what it is. And then a few little facts on what we feel we've done from our current farming and where we might go in the future. Industrial hemp is a member of the Cannabaceae family. Its cousin is hops. It's a naturally dioecious plant. It has individual sexes on individual plants. You can see the female and male plants in the two photos. They're very different. The male produces the pollen, which fertilizes the female flowers, which in turn produce the seeds. It's very fast growing. It's an annual plant, and it can grow between 1 and 5 meters in height. 1/3 of the biomass that you see above ground is also present below ground. It has a very deep, long taproot that can drill down into the bedrock, and that releases the minerals from the bedrock, bringing them up into the topsoil, and depending on how we cultivate and farm, should maintain the mineral content within the topsoil. Hemp by its nature is also very adaptive to environmental conditions, and it's very stress tolerant. So we farm hemp, and we believe it can help clean our water, our air, and our soil. And we can do this whilst maintaining biodiversity, productivity, and profitability. We don't see a need to farm in this method at the expense of other outputs and productions. So how do we clean the air? The hemp can sequester CO2. Statistics show that it sequesters about 16 tons per year per hectare, and that's in a 4 to 6 month growth cycle, so it's very quick. It's also very nutrient hungry, so it loves to absorb all the excess nitrogen in the soil. Last year and some of this year, to a lesser scale, we've planted around the reservoirs to prevent leaching of nitrates into the waterways. For the soil, it's very good. It provides aeration. The root goes very deep, and when we leave it in there and it decomposes, it provides aeration into the bedrock and the topsoil. We farm it organically. It can also be used as a remediator, so if we have contaminated soils, we can clean it. If those soils, say, have heavy metals, lead or something, we can remove that, and then we can dispose of that in safe ways to remove that from the environment. Through what Glyn does, we do a lot of composting, and we really use the waste that comes from the production and the manufacturing of the products. We use all that to make the compost. The hemp itself grows very, very densely, and it provides a very thick canopy. So this is great for biodiversity. If you come and look at our fields, the butterfly counts, the bird counts, the predatory birds. We have two predatory birds living at the farm now. I'm not an ornithologist, so I can't tell you what they were, but I think they're hawks or buzzards. Buzzards, are they? Yeah. So the chosen method of how we cultivate can improve the soil, and it can sequester carbon dioxide out of the atmosphere. We're looking to use precision drilling and no-till cultivation. We've been working on how to get this exactly right and how to minimize the destruction to the soil that is caused by plowing or other techniques. We, at the time of sowing, inject the soil with compost tea, and this is the bacteria and the fungi that Glyn has been talking about. And we plant cover crops to ensure that the soil doesn't remain bare in the patches between the rows or between the plants. We cultivate by nature no pesticides, herbicides, fungicides. The hemp plant is very resistant to environmental conditions. We don't irrigate either. Last year we had a very dry season. We still didn't irrigate. The hemp was probably the greenest fields in the island. We take the food waste, as Glyn mentioned, and when that's converted into compost, we apply that to our fields, and that really provides the carbon. We don't fertilize the plants. We provide the food and the energy for the microbes, and the microbes fertilize the plants. So we don't actually grow hemp, the bacteria and fungi grow it for us. We harvest it in sort of, now is harvest time, it's going on as we speak. Obviously there's impacts on how we harvest as to how much CO2 would be released in the production and manufacturing. We collect the seeds and the fibers. The fibers, when they are left to rot in the field, the breakdown of those fibers releases the nutrients back into the soil. Approximately 60% of the nutrients are returned. We intend to overlay this with compost, with soil amendments. We would like to include vrac and shellfish waste, and this will let the soil feed the soil over the winter months, and as we plant cover crops, and that will start to return the nitrogen into the soil that we've sucked out through the cultivation season. The end products will all impact on how carbon is retained. So the seeds we collect, we press them into cooking oils and protein bars, or protein powder, which can go to make protein bars. These are food products, so these enter the food chain. They're highly nutritious. The protein powder is the most complete plant-based protein, and they say pound for pound, it's better than steak. So we can farm in a carbon negative way whilst producing very nutritious and foods. There's a balance between obviously sort of arable and livestock agriculture, but the increase in veganism and plant-based diets, hemp will form a very important component to that. The flowers we harvest, we've now been licensed to harvest the flowers. These can go to make fragrances, nutraceuticals, and juices, and in some cases medicines. The fibers and the sheaves are ultimately the really large carbon drawdown parts of the hemp cultivation. The fiber, the stem of the plant is made up of hemicellulose, cellulose, and lignin. And approximately 50% of that is carbon. When equating to carbon dioxide sequestration, that one ton of hemp will have approximately, sorry, I'm getting a bit ahead of myself, but 1.63 tons of carbon is absorbed for every ton of hemp grown. This is carbon in its elemental form, so there's an equation to calculate that into carbon dioxide. It's a multiplication of about 3.6. We grow about 10 tons of biomass per hectare. We probably think with Glyn's methods we can improve that. Depending on the variety we can use, we could probably expect to get a maximum of about 20 tons per hectare. And this should sequester about 16 tons of CO2 per year. The DEFRA states that the cost of farming for CO2 emissions is about 3 tons per hectare per year. So this is taking into account conventional farming with the application of fertilizers and herbicides and machinery and various things. So in all of this, when you take that into feasibility, we expect that a field of hemp would have a net sequestration of about 13 tonnes of carbon dioxide per year. This is in a 4-month growing cycle, 4 to 6 months, and 1/3 of that carbon is retained in the soil. And so as long as we don't till it and break it up, that carbon isn't released back into the atmosphere. We can also double crop, so we can grow 2 varieties in the same field in the same year and receive 2 harvests from this, so we might be able to push these estimates even higher. What have we done to date? Last year we farmed 40 hectares, or so last year and this year we've done a total of 40 hectares. It's probably 50 tonnes of fibre. It's all stored up into our warehouse. If we can convert that into building materials, one of the potential uses of the fibre, then that carbon again is locked up into the houses. It's locked up into the structure of the house, which would be 100 or 200 years. Over that period, the carbon is also sequestrated by the hemp within the wall. As it breathes and lives naturally in a wall, it will absorb carbon dioxide again. It also regulates thermal temperature and requires less heating because of better insulation power. So we've done not a massive amount of farming. We've done about 640 tonnes of CO2 over the last 2 years. Jersey estimates 3 tonnes per person per year of carbon released. I suspect that's probably on the low side, but that's approximately offset the carbon for about 213 people. If we push that to 1,000 hectares, which is about 1/6 of the agricultural land in the island, we estimate we could offset the carbon for about 4,500 people with other improved methods of cultivation and implementing Glyn's technique of farming for bacteria and microorganisms. We can probably increase that even further, and all of that is achieved without the loss of productivity and profitability to our company. Thank you very much. If you have any questions, and please.
Just one of your slides showed statistic 1.63 tonnes of carbon per tonne of hemp. What does that mean? If you have a tonne of
this comes from the Department of Agriculture of Australia. The biomass of the carbon, the hemicellulose, the cellulose, the lignin that makes up the plant is in its chemical nature about 40 to 50% carbon. So the nature of the plant growing, photosynthesizing, as with all plants, takes that carbon dioxide out of the atmosphere, locks it up into starches, transfers it to the roots, to the growing shoots, and then converts that into the molecular structure of
the plant. I understand that, but it's 1.63
that number
of carbon per tonne of hemp grown. So you have a tonne of hemp, and that must hold the carbon. So how do you have more carbon than the crop?
You've got the 30% that's going into the microbes, bacteria and fungi, which are being fed by the plant. So you take it as a holistic figure.
Okay, so not just the...
Sorry. No, yeah, exactly right. That would include all the what's left and maintained in the soil, so that what we don't harvest. This is we harvest 1 tonne of hemp, but there's 1/3 of it is left in the soil. So
it goes back to that slide where with a plant and hemp grows incredibly fast. So in 3 to 4 months, we're up to 6 foot.
In some cases, we've got 12, 15 feet.
Yes, but per tonne.
Hang on,
So
it's planted incredibly.
the extra carbon is actually going to microbes, which then are dissociated from the plant.
So the plants are planted incredibly tight as well. So it's not like a tree where you've got.
Is that it's per tonne of plant?
Yeah. So 40% of the photosynthesized carbon, as I say, is in the top biomass, which is what they're benefiting from, which then made into hemp wheat or whatever pulls in all carbon.
So it's just the statistic.
So
I think there might be a mistake here. They've left out carbon dioxide and replaced carbon. So it's,
if you include the roots and everything, and exudates, I can understand it, but not if it's per tonne. you can't get more carbon than you have.
This is a stat I've taken from a document from the Australian Department of Agriculture.
Really
I would have to go and look at their calculations to really answer
Well,
your
it's just the
question.
understanding
But
of
we
just
can,
clearer, yeah.
I can give you the report.
Can I introduce Terry here, because we haven't finished the presentation before carrying on with questions. Would that be fair? Because there may be some more questions coming from once Terry's done his